Okay, so can you guys take your homework from week 15 and 15, 17, and 18 in last week's one? So we will quickly go through this homework to just review what we learned from last week. All right. So these several weeks, we focus on what? Polynomials, right? Polynomials. So focus polynomials, we know we want polynomials actually made of terms, all right? So terms, they made of the coefficient, right? Coefficient. And we want to know, find out their degrees, right? And multi-terms made of polynomials, right? Right. So let's review homework 15 homework, week 15 homework first. Firstly, see this one. Can you guys take your homework and quickly check this one? Find the degree of each polynomials. So we know the polynomial actually made of multi-term, right? Something like this one, 35 made of 3 terms. So the biggest one, each term have their own degree, right? Something like, say, this 35 made of degree of term, 3 terms, 1 term, 2 term, and 3rd term. Each of these terms, something like this one degree is 5, this degree is 1. From the exponent here, right, is 1, and this degree is 4, right? So their degree of this polynomial is the maximum one. So it's 5, right? 5. So find the degree, it means the maximum of each of the terms. Maximum, find each term degree and find the max of among them. So that one will make it easier quick to find out 36 here, all right? 36 here, degree is 2, right? Degree is 2. And for the second term, degree is 1, right? From here is 1. And the third one, degree is 0. 2, 1, 0. So degree is 2. Right. See 37. These are also 3 terms. The first term, the degree is, this is 2 plus 1. So you got 3 here, right? Degree is 3. The second term, degree is 5. And third one, degree is 4. So maximum one is 5, right? See 38. The first one, the degree here is 2 plus 2 plus 2, right? So you got 6. This degree is 2 plus 3, you got 5. And the third one, the degree is 1, here 1, here 1, so totally 3, right? That's the maximum here is out of 6. Right. Let's see 39. 39, he breaking down polynomial to each of the terms, find the coefficient and find the degree of them, right? So you can see this one, the coefficient, number show coefficient here is 1 here, right? And degree is 4. Second term, coefficient is 5, degree is 2. And the third one, coefficient is -7, degree is 2, right? And the fourth one, coefficient is 11, degree is here 1, here 1, so you got 2, right? And the last one, the coefficient is -1, so there's no variable, so degree is 0, right? So overall, the maximum one here is 4, right? The first one. So the degree for this polynomial, degree is 4. So the answer here, what's the degree of this polynomial? So it's 4. Right. Let's move on 40. So I'll talk a little bit quick because you guys maybe already know much better than this. Right, so next one. The surface area of a box, this is a box, right? Of a square base is the bottom, right? Square, so square base, it means this is square. So all x. And a height of 5 unit, height is 5. So here is edge, right? So here is the base, here is the edge. So given the surface area of this box is given by this. So actually you can see the top and the bottom is x squared, the top is x squared. What's about side? Side is 5x, right? 5x, four sides. So 4 times 5x. So you got 20x. You plus top and bottom, right? Totally is 2x squared plus 20x. Exactly like this come from. So you can see fill in the table below by evaluating this one for the given x. So if they told you x, you can find the results, right? So actually, if it 1, you can see this one result is 22, right? If the 3, so here is, so you guys can quickly do 2 times 20 times 3, all right? So the left, I will let you guys finish the rest. The number calculation would be easy for you guys, right? Just fill in a number and you can get the answers. All right, so let's move on next one. Combine like terms. So let's move on next one for combine like terms. Like terms, we talked about like terms, right? Like terms is the variable part should be exactly the same. Variable should be exactly the same. The exponent also exactly the same. Only different is the coefficient part. So when they do the addition, you just need a coefficient part to do the addition, right? When I do minus, only coefficient part do the operation, right? So you can combine like term like this way, right? So only the coefficient part do the operation. The rest part didn't changing, all right? So this part, so we can quickly get out of here, right? 7 minus -4 minus 1, so you got a 2a squared, right? Like this one, so they are like terms, right? Y part like terms, so you can, okay, here is 10, so you got -4 here, right? What about this one? This 2 is like term, right? So you got 15a squared, the rest part, this term is not a like term to others, right? 44, see 44 here. So you can see what like terms, this one x squared, so you can get 22x squared and plus 3x and plus 6, right? So here, there's no like terms. Here, no like terms. So just keep it as it is. Let's see 45. 45. You can see this one, a squared b, right? A squared times b. A squared times b, we find here, a squared times b is this part. This one is the same, is the like term, right? So you can get a -6 a squared b. All right, so the second one we find b squared. We didn't find b squared, only one of them, right? Only one left. So we copy here. Copy here. And the last one. And last one, this 2 is like terms, right? Q squared, right? All right, let's see 46. 46. You can see this one, the degree is 14, degree 13, degree 12, degree 10. There are no like terms, right? Degree 14, 13, 12, 10, and no like terms. So this one cannot be combined, further combined, right? Just keep, so leave alone. All right, let's move on here. 47. 47. Oh, sorry. So see 47 here. 47. So this part, actually, firstly, we just need to get rid of add or subtract as indicated. So this means we needed to combine like terms, right? So we can get rid of this parenthesis first. Okay, so you can get, so the rest is combined like terms. You guys can do this quickly out of here, right? So you can get a squared, and these 2 is the like terms. This became 3x, the rest, right? All right. So see next one, 48. So first, this is plus. We can get rid of here parentheses first, and then we find the like terms. Like terms, 2x power 5. Power 5 here. Only one of them. We didn't find the rest, so we copy here. Let's see second one. Power 4. Power 4. The rest don't have it, so we just copy it as well. Power 3. Power 3 only one, right? So we just this one also copy here. For the power 2 square. So this 2 is like terms. So we got x and 7x, right? So only these 2 is like terms. All right, let's move on next one. 49. So first we needed to get rid of these parentheses, right? So you can do 2 steps. Sometimes people, if you can do quickly by in your mind, you don't necessarily do two steps. You can just do 1 step. So you can see this is like terms, right? So -5 here, -2. So you got a -7y squared. And powers of 1, they don't exist, power 1 either. So this is 3 minus 4, right? -4, 3, so -1. Okay, let's move on. 50, the same. We need to get rid of the parentheses first, all right? So first we'll find this like term, 3 minus 4, right? So -x squared. Second one. So you can see this 2 is like term 7, -7x. This is plus, right? You distribute inside. So you get a -6y. And the third one here. And negative means -9. So you got a -2y squared, right? All right. So I will keep this. I skip this one. So this will be easy for you guys to do the rest. All right. All right. So I will skip 51 to 54. Let's move down a little bit further. So actually situation. What are actually situation? Like this one. 76 to 76. 73 to 76. This is about actually geometry. Let's see this part. Recall that the perimeter of a figure, such as ones shown in this 73 to 76, the sum of the lengths of each side, find the perimeter of each polynomial. So that will be easy for you guys, right? Perimeter for each of them. Because of, you can see the perimeter actually is each side of these kinds of figure to find them, the sum of them. So you can see some of the sides like 9x, 3x, 4x, and 2x. If you plus, actually, if you put it together here, it's like 7 plus 9x plus 10 plus 3x plus 12 plus 4x and 15 plus 2x, right? So like this part is like terms. And here is like terms as well. So you can get 12 plus 6. So you got 18x, right? So here you can get the numbers, constant numbers, right? So this part is easy, right? 73. So you can get here 17 plus 20, 17 plus 17, 29, 29 plus 15 is 44, right? 44, yeah. So the same for the 74. So you can got the perimeter. Actually, you need to find each side of them and combine the like terms, right? That's easy for you guys. All right, see 74, I will skip. Go to the 75. So you can see this triangle. The side is actually a little bit extended, right? So the perimeter is 3 sides. They plus together, right? plus 2x squared plus 5. And the third one is 4x minus 1, right? First side, second side, third side. If you just like what I'm doing, based on degrees of 2, degree of 1, and degree of 0, and so you can easily get a result, right? So you can get here is x squared, here is plus 7x plus 4. This is the final results, right? 76, same, 4 sides. So you can this part plus this part plus this part and plus this part, right? So you combine like terms after that. So okay, all right. So let's move on. 47. 77. I'm sorry. 77. A wood beam is such long 4x squared plus 4y plus 1. If one of the piece is this part, what about this part? So it means this one minus this part got the rest, right? All right. So what about this part? This part is 4y squared plus 4y plus 1 minus this, right? So you can get 3y squared plus 4y and 1 minus 1 plus 10, right? So you get 11. So you can get it here. So the expression, all right, the same for the 78. Same for the 78, right? So this part minus this part, you can get this one, right? So for the adding and subtract polynomials, I will leave you guys to do check by yourself. For the 82 to the 86, they're similar. So especially pay attention to the like terms. Let me pick one of them here. 86, all right? Because of a little bit complicated, they have 2 variables like this one. So be careful about the like terms, like this part, a squared y. And you can see this part is x squared y. You can check each of right here. You can see the last one here, 5y x squared. So this one actually can proper change, right? So these two actually is like terms. These two is like terms. So 3 minus 5, after you distribute it inside 3 minus 5, you got a negative 2x squared y. xy, you didn't find. For the second term, only have this one, right? For this part, let me check this one because we used this one already. So here is positive. Here is like terms, right? So you can minus 10x squared y squared. And last one, 5 plus 1. So you can negative 4. Right? Combine like terms. Most important is how to identify like terms. Okay. All right. So I will skip the rest here. Let's go to the review part about multiply. This one I have leave some homework about the multiply of the one term times one term. So this one just exponent part. Actually, we do these kinds of topic already, right? Right. So let's quickly pick some of homework finish here. So like one term time another term. So is coefficient part. Do the calculations. The rest x times x, so became x squared, right? So 92, same. So here is negative 7x squared. I think this is pretty easy for everyone here. 93, here is negative 12x. So here is became 8, right? X cubic, x power 5, 3 plus 5. So you can get it here. So here got a 42R13, 3 plus 10, got it here. Let's see 95. This is also two term. When I do the multiply, so here first coefficient part. calculation first, right? The second is the right part. So you can go to x, here is 2, here 1, so you go to x power 3, so x cubic, y square cubic it is. And the last one here, so you can get negative 11 z power 3, right? Power cubic, y square. All right. So homework part. So the rest here 97, how to describe the degree of a term. I think this one we talked about a lot, right? So degree is at all sum of all variable exponent. Secondly, 98, how to describe the degree of a polynomial, yeah, the maximum one of each terms. 99, explain why x, y, z is a monomial while this is a trinomial. So this one is by x, y, z. This is one term because they are timed together, right? It's have a one coefficient and 3 variables. And these 3 is actually based on addition, connecting together. So we can split x, y, z into each of their terms, right? Right. 100. Explain why the degree of this term is 3. We just use the exponent of variable. So of course, this one is 3. And the polynomials, this one degree is 1 because of this degree, each of the term in this polynomial, the degree is 1, right? So after they are combined like terms, it became 5y. So the degree is 1, come from here, right? Okay. So this part is easy for you guys. So I will skip the rest. Skip the rest, and we go to next part, next section. Let's go through the homework. Homework, I think is 15. I'm sorry, 17. 15 we just finished. We go to 16 is the last week of last quarter, right? So no homework for that part. We exam. We go to the final quiz. So let's go to the 17. Week 17, actually, I left some homework actually similar as what we do homework for the week 15 actually is adding and subtracting polynomials. Right, so I will pick some of them here to do the same. Is try to find adding and subtract polynomial. Actually, the work is combine like term, right? So the homework is the same as the previously. Hopefully you guys can use this homework to repeat and make sure you can find out what's the like terms and what is not like term cannot be combined together. All right. So this part is relatively easy. Okay. So I will pick 1 or 2 here to check our homework. Let's see the 13 here. Let me pick some of them. 13. See 13 here. Everyone can see 13 here. So like this one actually made of 2 trinomial, right? Trinomial. So they only have 1 variable in this, only x, right? Only x. They don't have x or y. They have 2 x, only 1 variable in this expression. So we can base on the degrees. Like this one, the degree is 4. This degree is 5. This degree is 3, right? And the degree here is 3. Degree is 5. Here degree is 4. So you can see the same degree they have became the like terms. So first, these 2 is like terms, right? So you can quickly get out of there. Is here became 6x power 4. We find the maximum from first. Power 5. So here became 18x power 5, right? Power 5, power 4, and power 3, 1. So here go 12x cubic, right? Right. Okay, let's see the next one. Next one. 15 here. So you can see all the expression here, only one variable, right? Is n, right? So you can see this is degree is 2, this degree is 1, and this degree is 4, right? And degree is 2, degree 1, and degree 4. So we can find the maximum one first, degrees of 4s. So you can get a negative 8 n power 4. There's no degree of 3. We leave space here. With a degree of 2. So here actually became 0, right? And degree of 1, degrees of 1, when you combine, so it became 8n, right? And degree of 0 is nothing, right? Here also 0. So actually, we just like write like this. That's it. That's it. So do you guys have any question to this combined like terms? Combined like terms relatively easy, right? The first thing you just need to find out what's the like terms. Okay. All right. So I will finish some more example here. Let's see 26 and 28. They have the two variables. Maybe we can finish these three before we finish this homework review. Okay. All right. Let's see 26. 26. So you can see this have two variables. One is u, one is v, right? So we need to find the same like terms. Be carefully, right? First, we find u. We can find like this way. You can see here is v square. So we check this offline. V square. We find v square here, v square here, right? So we can get what? So here, combine these two actually became 0. So here became v square. All right. We then find second one, u square. So let me use a different color. U square. So only one of them exists, right? So we can just right here. And third one, we find the uv. Right? So we can combine, became 2uv, right? We didn't find, this one didn't used, right? So we copy here, right? So make sure you finish, you have combine all the like terms and copy the one without combination down here. Don't miss any of the terms, right? Let's see 27. So here you can see this expression have two variables, x and y, right? So you can see the degree of here is 2, the degree here is 5, right? And degree here is 2, and here is 5, and here is 1, and here is 1, and here is 2. First, the maximum, we find the maximum degree one is this one and this one. After the combine, here became 14x cubic. I mean, x cubic y square. Second, we find the degrees of 2, only these 3, right? Let me use different colors. This, and this, and this. Be careful about this one. We need to distribute inside first, right? Normally. So 4 plus 6 and minus 9. So you got a 1, right? So we can x squared. So we use this already. So the last one is this one. Negative 4x, negative 10. So you got negative 14x. So most important is find the like terms. I know you guys may learn this already, so maybe too easy for you guys. All right, so let's see the 28. Let's do one more of them before we finish these kinds of combined like term homework review. Sounds good? All right, so let's go quickly like here. So the degree of this one is 7, right? Here degree is 1, degree is 7, degree is 1, and degree is 4. you can degree here is 6, degree is 7. All right, so you can see which part. The degree the same means they are possibly like terms, right? So we can see this one first. Second is like terms, right? So up, and the last one here. So we can use -5, -10 plus 8, so became -2. Second one, we find a 6, only 1 6 here. So definitely there's no others. You can just copy here. And goes down 5, there's no 5. And go 4, only 1 here. So we just copy here. And 3 and 2 and 1. 1 is only 1 here, right? So you can V. So we can easily finish the rest. Right. All right. So I will leave you guys homework to yourself to check by yourself. All right. About the like terms combining. So let's go to last week homework. Last week homework actually we moved to multiplying polynomials. Polynomials actually just like your terms. You guys maybe like to use what I suggest use the rectangular methods, rectangular area methods. Firstly, like if later only 1 term times 2 terms, you guys use the distributing methods, right? You can use the distributing methods. This very well. Distributing methods, you can did it like these two, right? So you can get the 35V here minus 56. But distributing methods, this is very easy for you guys, right? So you got the -4x squared here, -6x, right? Distribute methods. Distribute methods is relatively easy, right? All right, when there are 2 terms by 2 terms, when there are 2 terms by 2 terms, how you do that? 2 terms by 2 terms. Most of you guys maybe use the FOIL methods. FOIL methods. What do you mean? Actually, you can consider this is 1 term. Most people say consider one distributed inside like this. So consider first one is 2 term distributed inside, right? Right. After that, you can see this is 2 term by 1 term, 2 term times 1 term. So you can still use the distributive methods. So you can 12n squared plus 12n. And here that's 2n plus 2, right? So distributive methods. You can second distributive methods. And after that, you combine like terms, right? So after that, you combine like terms, like these steps. You can so if you use the FOIL methods, you guys use the FOIL methods, first term, first term, first second term, second first term, and second term. You can also do like way, so you can got a list step. Actually, second FOIL method is got list step. First step, actually, you consider this as a term distributed inside first, and then your second step distributed inside, and you got this part. Of course, you can use our methods earlier. I talked about is the rectangular area methods, right? So you can first is 2n, and here is 2. Here is 6n, here is 1. So this rectangular area became 12n squared. This rectangular, here is 6n, right? 6n, so you can 12n. So here got a 2n, here got a 2. So you can see these 2 is like terms. So actually you can see 1, 2, 3, 4 is exactly match up here for rectangle, for small rectangular area, right? So combine the like terms, you could get this part as well. So multi-methods. So you can use the 2 distributed methods. You can use the FOIL methods, or you can use the rectangular methods, area methods. Right. So it's easy to do this. Right. So like this one. So you guys can quickly do in your mind. use the FOIL methods. Like this one, you can got an squared, right? But the 24n plus 2n plus 6. That's FOIL methods. So you also can get an squared plus, here got what? 26n plus 6. Right? Easy part, right? Easy part. Okay, so let's see this one. So you can, let's do this way. So use the FOIL methods. You guys maybe family more like to use the FOIL method, or you can use the rectangular methods as well. Sometimes because of rectangular area methods more visible, something like x, here -3, here is 6x, here is -2. So you can go 6x squared, here became -18x, here became -2x, here became +6, right? So you can see this degree 2, this degree 1. So this 2 is like term. So you can get a 6x squared minus 20x plus 6. See, one step. You can graphing this one step, get results, right? Like this one. So you can use the FOIL or distributive methods. Depends on which one you prefer, okay? That depends on you really like to, which one you make it more easy to remember or easily to use in near future. So you can do by yourself, by your way. Try. That's why we need to practice many times so you can familiar which method is best fit for yourself. So like this one. Firstly, you just like we say, you can use distributive method. Consider this is one term. All right. Consider this one term. So you distribute it inside. Right. First is distribute to 6p, and second distributed times 2, right? And then you distribute again, distribute it inside again. So you can 68p squared minus 12p plus 16p, right? Minus 4. And then combine like terms. That's why we need to spend some time to combine like terms, because of, so here got the plus 4p minus 4. All right. So in near future, we will do backward. Maybe the challenge part. This called, this one do multiply. Next one we do a factor. How to factor this one from here to here? Maybe the challenge part for everyone. So we didn't talk about this one yet. So we will talk about this one seriously a little bit later. So you can do this step by this way: 1 step, 2 steps, 3rd step. How you go backward to get here? If I give you this one, can you guys go get this one? Think about it. Think about it. All right. Think about, keep this in your mind. So we can, how we do that one. All right. All right. Let's move forward. See 11. Brian, I'm sorry, Brian. Go play, Brian. All right. See number 9 here. Number 9 here. So easy methods do this way, right? So you can do the rectangular methods, which depends which one you like, all right? So you can do quickly get the answers out of there. First is 6p plus 8, right? Second one is 5p minus 8. So you can get here is 30p squared for this small rectangular area. So here is 40p, right? 8 times 5p. Here is negative 68p, I'm sorry, 648p. Here is negative 64, right? So combine like terms. Here, these two is like terms, right? So minus 8p minus 64. In near future, we want to give you this one, how you find this one, okay? So keep this in your mind, how you do that later. All right, so this one. So we can, if you can do more already very familiar this path, maybe can do 1 step. You can got a 24m squared, right? First. Second one is negative 21 minus 8, right? 21 minus 8. So you got the what? 21 minus 8, you got 14, right? I'm sorry, 21n minus a plus, I'm sorry, here, plus minus, so actually you got 12 right here. And you got minus 7. Sometimes make sure you family list progress easier, so you can get right. Okay, so C to 11. So you guys can one step get the answers. Did you guys can one step get answers? So 16a squared, right? Here's minus 10, minus 8. So you minus 18a, right? Plus 5. So if you family list progress, you can just one step get the answers, like this one. So it's 25n squared, right? Minus 25 plus 30. So you can plus 5, right? See, one step, you can get all solutions. If you family list progress can make it easier. All right. So actually today we will move some new topics. A little bit later we'll move new topic. We'll including these kinds of square. We'll talk a little bit more right, about this part. So I will leave this one for later. What are the new topic here? All right, let's go 14. You guys can do this one quickly out of there. Write one result out of there. So it's 35x, right, square. Here is minus 42, I'm sorry, 42x minus 30. So you got a 12x, right? Minus 36. One step, right? Okay, can you guys do that? 36n squared is minus 24 plus 18. So you can minus 6x, right? You guys can do these kinds of in your mind. All right, so first you get the 48n squared minus 24 plus 6. So you got negative 18, right? Yep, you should be able to do this quickly out of like this way, all right? With one step. The more you do, you can make you more quicker get this out of here, right? So that's why we need to practice, need more practice. All right, so let's see the 18 here, some 17 here. So you got the 30k squared, right? Can you guys get it? 30k here is 30, right? 30 plus 25, so you got a 55 plus 25, right? Last step. Same here. So if you're not familiar, you just try rectangular here quickly, make you a little bit, you don't necessarily keep in mind too so much. You can just do this progress, right? Something like here is 12x squared, right? This small rectangular, and here is minus 16x, here is 9x, here is 12. So you can just say here is 12x first, second here like terms, it became negative 7x minus 12. Also one step, just need additional thinking about here, right? All right, so we move a little bit more complicated case. Like this one is 2 terms, here is 3 terms. The same, actually result is the same. So firstly, we do like this way. All right. So here are 3 terms, right? Here are 2 terms. So here you got a 4a, here you got a 2. Here you got 6a squared, here's minus a plus 2, right? So you can get here is 24a cubic, right? 24a cubic. What about this rectangle? Negative 4a squared. What about this one? Here is 4a, 2. So you got a, right? What about here? 12a squared. Here it became negative 2a. Here positive 4. All right. So you can see like terms. This 2 is like terms, right? And this 2 is like terms. You can see this is like somewhat, you can see easily find like terms. So what the result would be? First is 24a cubic. This one became 8 a squared. This one became 6, right? Right? And last one, 4. 6, see? Do the same progress. Same. So you can graph. Don't. So if you're not familiar like this progress, you'd better just write like this way, right? Called rectangular area methods, make you easy to get. First 7k cubic. Second one, negative 2k, 7k. So you got 14k square, right? So here got a 49k. Here got negative 3k square. So here became 6k, and here negative 21. Here negative 3, here 7, right? So you can see what's this 2 is like terms, right? And this 2 is like terms. All right, so easily we can copy the rest. 7k squared. Here is negative 17k. I mean, sorry, here is k cubic, here k squared. And here you got plus 55k and minus 21, right? So that's the results. That's the results. All right. So we talked pretty much about the same one. I will not tackle the rest of the, not finish the rest of them. And the rest will be very similar kinds of methods, exactly the same methods. So you can finish the rest. All right. So let's take a 5 minutes break and come back to begin the new topics. Sounds good? Anyone have questions? Anyone have questions? Nope. All right, just 5 minute break. Come back 3:55. All right, sounds good. All right, see you soon.